Hi, welcome to my video number 5, I think number 5. Okay, so in this video I will cover global variable and local variable. I'll explain to you what is global variable and local variable. I will also explain to you the use of mathematical operators, how to use that in C. Okay, so let me begin this with again with the structured program that I explained to you many times. Our structured program is we have include standard input output there, then we have main, we have open the and close brackets. Okay, and this part here is the declaration statement. Now if we consider a structured program, you have a main program with many functions inside that we developed. So let's say we have some function here. This is considered as another sub-program in the program. We have a main program, then we have sub-program. For the sub-program, let's make it a little bit bigger here. Okay, for the sub-program we also have the same structure there. Okay, and here we also have declaration statement. Here also we have declaration statement. Okay, now the difference between this declaration statement, where we define or we declare our variable, with these declaration statements, the variable that we declare here only applicable to this function only. Okay, this function. Example, if I say here I put integer, let's say give some number a, so this integer a can only be used in this function. If you use this a into here, then it will give the error, because this a will not recognize here. For this case, we call this as a local variable. Okay, whereas for this, yeah, we declare here, example, I put integer b. Okay, so this variable b is recognized in this function, means we can use this variable b here with the same type. And of course, if you want to put the value, you want to use the same value here, we have some argument here that you need to call in that value. So in this case, we call this as a global variable. Okay, so we can differentiate between local variable and global variable. Global variable can be used here as well as can be used here, but for the local variable only can be used in that particular function. Okay, now we go next to the operator that we use in C. Normally this operator is used to perform the mathematical sentence, mathematical work. Give an example here. We have for multiplication, we use star stand for multiplication. Example here we have x star y means x times y. Division, that symbol as a division. If you use a standard division you know, this symbol, then when you compile, it give you error because C does not recognize this symbol. So we use that. For addition, we have plus. This is x plus y, means x plus y. And we have subtraction, we use minus, and this is stand for modulus. Modulus means, if you learn in algebra, right, modulus means I give you example. 5 mod 4, that give you 1. Yeah, 4 mod 4, that give you 0. Okay, so where is 1 come from is, if you can make 4 divided by 5 divided by 4, 5 divided by 4, this is equal to 1 over 4. So this 1 is here. Okay, the balance of 5 divided by 4. In this case, 4 divided by 4 is 1 and has no balance, so we have 0. So this is the definition of modulus. Now, all these example of modulus operator. So you can see here 8 mod 2, that give you 0, because 8 divided by 2, that give you 4 with no balance. Alright, 5 mod 5 is 0, and so on. 5 mod 3, you got 1. Why 1? Because we have 9 over 3 is 3, so we have 1 more extra, so that's 1 there, and the rest of it. Okay, and then this is the example of multiplication. So we give initial value, expression 1 is 4, expression 2 is 7, and then we multiply, so this symbol stands for multiply. Right, so this is for division. For division, we just use that. This is a simple program, a simple program. We add 3 numbers a, b, c, where we define a at the beginning of our programming. Alright, this is the declaration statement. This is the value that we put in, and then we do the process here. This is the process. So we just sum up all those things, and then the answer, you can see a plus b plus c. The answer we give it to sum. So sum hold the value of a plus b plus c. When you print, you can just print sum here. Okay, this is the way we print to get the output. So output, you can have sum is whatever value there. Okay, this percentage d, that d, this is because sum is integer. We define sum as integer, so we need that d. That percentage shows that this is the place where we need to put the value of sum in the output. Alright, and this /n shows that if you have another print down there, then next it will print in the next line. You should not print straight here and continue there, but it goes to a new line. Okay, this is another example. Okay, another example. So in this example, we calculate the modulus. So we define integers, sum, and we give the value, sum is 50. Then modulus floats. Okay, modulus value, the type of that is a float. So modulus is sum mod 10. Sum mod 10, you have sum is 50. 50 over 10, that give you 0. Yeah? 50 mod 10, that give you 0, because 50 divided by 10 is equal to 5 with no left, no remainder. Alright, so that gives you 0. So when you print out here, you can see we have a percentage here, we have percentage here, then another one is here. So you can see this shows that the modulus, okay, it stands for modulus. So I would prefer, if I would prefer to write modulus here, but since we understand percentage as a modulus, so this is modulus of that goes of 50 here, sum goes to there, because sum is integer, so we put d. So that part for sum by 10, then this part is modulus. You can see modulus is floats, so this percentage ff is for floats. So modulus will be written there, the value for sum will be written here. So we have the output is given by that. Okay, 0.000, because we define modulus as a float. Now next is the order of evaluation of arithmetic operation. This is as we already know, normally we begin if you have parentheses is the priority, then between this star they evaluate multiplication, divide, or the modulus, and if they are in the same line, normally evaluate from left to right. So this is just a normal mathematical evaluation. Okay, and then plus minus. So if you have parentheses, we solve the whatever in the parentheses, then we do multiplication or division or mod first, then after that we do plus minus. Okay, these are some of the example. Okay, these are the examples. So you can see here 7 times 4 is 28 plus, so you got 33. You solve in the parentheses first. 9 times 7, you got 63, and so on and so on. Okay, those are the example. Now when we deal with division here, you need to be very careful. Yeah, result x by y. If you look at here, x is integer, y is integer. Okay, so here you have integer by integer, so the answer you should get integer. So what happened here, 8 divided by 3, so 2 point something, that something is less than 2.5, so that bounded to 3, 2, sorry, to 2. Okay, so if you want to make it float, so we need to define result as a float, and here you need to fracture. This is example. Okay, floats of x divided by y, so that will give you the exact value. Okay, what is 8 by 3? Then for the increment and decrement operator, yeah, for decrement means for the increment means we increase 1 by 1, 1 plus 1 plus 1 plus 1. We can use plus plus x or x plus plus. For the decrement, we can use minus minus x or x minus minus. So I'll give you an example on how this thing works. Alright, okay, this is the example. Okay, so if you write a equal to b, x equal to a times b plus plus, so it means that this is post increment after the process we do. So means that we do the process first, x is a times b, then the increment for b. Okay, increment for b. And for this, decrement first and then do the process. So decrement first, we do the process. So you can consider this. You can write like what happened if you write x equal to a times b, x equal to a times plus b, plus b. So what happened in this case, okay, we add b first, b plus 1, then x equal to a times b. So you can see the difference between these two. This one, we have x times a b plus plus, so which means we do the process a times b first, and then we increase b. Okay, in this case we have x equal to a times plus b, which means we increase b first, then we do the process a times b. So what is the difference between those things? For in this case, if we put, for example, a equal to 2, b equal to 3, example for this case, so what we have, the output here, b plus 1, so b is 3 plus 1, that give you 4, then your x is 2 times 4, that give you 8. Okay, whereas the other one, if you write x equal to a times b plus plus, this will give you x equal to a times b and b equal to b plus 1. So if you use the same value of a and b, so the output for this is that we have x equal to a is 2, b is 3, that gives you 6, and b equal to 3 plus 1, that equal to 4. So after that process, b equal to 4. In this case, after that process, b also equal to 4. But the process for x a times b, this one will be do after the increase b, but this one before b increase. So that's the difference. Okay. All right. Now I have some more here. Example. So you look at here, post increment. All right. Integer counts, integer index. If we do this, index counts is equal to index plus plus. This is the same as. Okay, I wrote here. Here counts is equal to index. Then we increase index. Okay. Then we increase index. So if you look at that output or answer, we have counts. Index is equal to 6. Initial value 6. So count equal to index. So the value of index, we give it to count. So the count has the value 6. And then we increase index. 6 plus 1, that's 7. So we have index is 7. So count is 6, index is 7. So we have this. Whereas for pre-increment, this is we have plus plus. You can see here the difference. Okay, this is index plus plus, but this one is plus plus index. For this, we increase the index first, then we give the value index to count. So which means the initial value for index is 6. So 6 plus 1 is 7. Then index give the value to count. So which is count have the value 7. So we have count 7, index is 7. Okay, so same thing for the decrement. Same thing for the decrement. So you can see here this is count. So which means in this case we do count, give the value of index to the count first, then we decrease index. Okay, for this case you can see minus minus index, which means we decrease the index first and then we give the new value of index to the counts. So that's why we have count is 5, index is 5. In this case count is 6, index is 5. So you can see the difference between those things. Okay, then the rest is another example. Okay, another example. In this case you're going to have the same value here, and you can see the output is, because the initial value for x is 10, so here you have x plus plus x, that give you 10. Here x plus plus also give you 10. Okay, if you write like this, the value of x just the same, because it's increased and then print. Okay, the difference with the previous one, because we have process here. We have process here, count equal to index, count equal to index. But in this case, we just just increase the value, so it gives no difference. This is for the rational operator. Okay, equality and relational operator. So for equality, we write x equal to y. We cannot write equal to y. X equal to y give no meaning, so x equal to y. So which means x equal to y. This is not equal, and all those things you don't have to worry, because you can memorize this easily once we do the programming. Okay. All right. That's example. I'm going to stop somewhere. Another example for the use of relational operators, and given the output there. This is for the arithmetic. For logical error here, normally this logical error. Okay, logical operator. We use this normally with condition, like when we use if. Yeah, if A equal to B and B equal to C, then those kind of thing. So we use that operator, that symbol. Okay, and this is the you don't have to worry about those things. This is a machine will do it. This is an example of using that. And then next is the math library function that I'll give in the next video. Now for this video, I stress on what is it? On the global variable and local variable, as well as the operators, mathematical operators, that plus, minus, division, multiplication in C. So we are not doing any programming yet at the moment. Just I give you very simple example. Later on, when we have when we arrive at the certain part, then I'll explain more on the programming. Programming is the C itself is not difficult, but the logical thinking behind that is important, and it is not unique. Depend on who is doing that programming, the way you think. Okay, so for the time being, I stop here. Thank you.